So, door is closed, we can start. So, who is actually working here in CERN? Is someone here? CERN native? Wow. And who is, how to call it, physician? The true one? Physicist. Or physicalist? No. And who is a mathematician or something like this? No. Just software engineers. Very good. So I did some research, and I said, okay, you invented a new stuff, right? A few weeks or months ago. And something with the muons on electrons, and this was somehow interesting. But then, on YouTube, then the next idea was that you try to open, the gate to hell. And I say, oh, that's interesting. What research is going on, right? So I was like, I have to come immediately and check out what's going on here, right? So today I would like to talk about serverless Java. Why? Because most of my projects are serverless right now, and maybe to tell you the ideas. And you can challenge me at any time and say it will never work, or as always. I really like the interactions. So I basically don't care. I'm a freelancer, consultant, and I do whatever fits. And in some projects, serverless fits perfectly, and in others, doesn't fit at all. So that's the truth. So and today I would just like to explain what it is and when it is good. It doesn't mean you have to do this, right? Like it's the same as microservices, whatever. And especially interesting, for CERN people have always priority. We are already guests at CERN, right? So this was fun. At a conference, someone assumed I'm working for a huge company named ERHEX, and this is, of course, now a company. This was just a longer story, but this is my domain, nothing else. And I immediately afterwards registered ERHEX Industries. So you'll find all the links to GitHub and Twitter, whatever, right? So this is just collection of links. And some workshops in summer. I don't have time to do more, but this is an open workshops. They are online. One is about persistence, cloud native, something similar what you asked before the show, and the other one is how to integrate AI, because I think this is the next challenge, is knowing what it is or what we can do with it in enterprise. So everyone asked me about that, and there are already some ideas how to do that. So I will try to spend the entire day with it. Both workshops are guaranteed to run. Already there are sufficient registrations. Okay, now just a few slides, because all my talks about serverless without any slides were a catastrophe. It didn't work at all. So first, green IT and cloud native. So the first one, this is like from Google research. Is an old one, but I really like it. Why? What do you see here? That Java is actually very energy efficient and very fast. And this is the key to success in my projects. Not because it's green, I like green, but managers don't care about greenness. They care about more about money, of course. But in this particular case, green and money are related in serverless, very related. What do you see here on the slides? Java is like, the C is the fastest, of course. Java is one close to 2. And Python is 75. It means Python consumes 35 times more energy than Java, and is also 35 times slower than Java. So what means if you would like to save energy at CERN, you have to use Java, right? So and this is the first, best practice at CERN. To, you can run greener protons around, right? So now, so this is about costs. So I'm doing strange things like Azure Blob Storage or S3 or DynamoDB, not because it's nice, it's because cheap. So this is a thing. It's not like I don't like JPA anymore. JPA is nice, and hash maps are nice sometimes, and in other cases are really ugly, but you can run them for cheap. So this is the entire story. So whatever I told you today, from my perspective, clouds don't make any sense if you don't have a budget to talk about, or the costs. Without costs, no architecture. So whatever you ask me, I say maybe. It really depends how much money you have and what is the performance profile of the application, right? So next one. What this is a common question. This is AWS Lambda. And what I did, I exaggerated a bit. I said, okay, I have 2 gigs of RAM, which is this is actually a lot for Lambda. And I'm running 2 transactions per second, night and day, the entire time, and it will cost me 15 euros. And this is why I get the projects. Compare it to something different, it is far more. But if I will have 200 transactions per second, right, are 1,500 euros. So it means in one point of time, if you run bare metal, it's cheaper. But most enterprise applications are not 2 transactions per second over time. Right? There's maybe a peak 10 transactions per second, and weekends nothing, and vacations nothing. So over time, most of the serverless projects cost basically nothing. That's the trick. So, and to understand as Java developer what serverless means is, what serverless means, it means just the perfect auto-scaling, right? So, so serverless is not cheap, it is more expensive than bare metal, of course, 20-30% more expensive. Why? The margin of the cloud providers, of course. But you pay per call. If you pay per call, you pay for the call and not what happens between the calls. So if you provision hardware, you have to pay all the time for the hardware, and you are only cheaper and if you can really use the hardware by a 100%. You got me? Okay, so no magic. So we have web scale applications. Whether serverless fits here, not sure. But most of my projects are not TikToks on YouTubes or whatever. It's more like boring enterprise applications. So in this particular case, so applications, reports or whatever, in an enterprise, serverless is perfect. Not only from the cost perspective, also from security perspective. Why? Because we don't run Docker anymore, basically. We say on Azure, just pick the Microsoft JDK, on AWS, pick the Corretto, and they are even patching the JDK for us. So there is nothing to audit, nothing to document, nothing to operate, which is great in enterprise, and nothing to document, which is great for me. So actually, in one project, they demanded from me to write the operation manual. It was like how to operate S3 storage. I mean, it is just there. I cannot just reboot it or what I should do. I can just provide you some data, but there is no way to improve the situation. The same is for Lambda. So basically, no kidding, no ops is true right now if you do this. Okay. Questions? So you have to ask me questions, or what's wrong with you? Usually at this particular case, they will tell me, okay, you are completely wrong, it will never work, so I expect stuff like that. Okay. So I got, I think, a good idea to explain serverless. So in 1999, at the beginning, this is what I did. There was an Apache HTTP server, still remember, right? And there was mod.jk, mod cluster, mod proxy. And what this did, you can, from the architectural perspective, think about this like the Apache HTTP server received the call, created a binary event, and sent the event, let's say, to Glassfish, or Tomcat, and Tomcat parsed the event and did something with it. Okay? Everyone saw this, right? So now the cool story is Azure Functions or AWS are identical, no difference. What's different is that we have an API gateway. This is HTTP or REST API gateway. It can be load balancer. What it is depends on costs again. If the traffic is low, gateways are less expensive. If the traffic is high, load balancer is more expensive, less expensive. Why not always take to load balancer? Because there are fixed costs for load balancer and you need the network. So you don't like to pay entire time, just on demand, okay? And the events are JSON events. They are not standardized, but you can look at the events and use them for testing. And what I use in all my projects is Quarkus. And why Quarkus? Because I don't know whether you saw talks in the past. I used Java a lot. Why? Because back then, vendor independence or whatever, and there are still a lot of Java projects, and there are still nice code. MicroProfile for me is all the same, whether MicroProfile, Java, the same code. Basically, you only need add inject. But now the cool story is, if you pick Quarkus, what Quarkus does, Quarkus understands the event, actually understands two events. One event from the application load balancer and another event from the gateways, but in both cases, and you don't even know it. So our business code looks like 10-year-old code, but this is completely serverless. We don't need any proprietary frameworks, it just works. Okay? And the cool story is, why, who knows, I talk about this all the time, why I started with 2 gigs. Why I started with 2 gigs, what you see is that the memory starts with 128 megs and goes to 10 gigs, right? What you don't see here is that with 10 gigs you get 6 CPUs, and with 128 megs of RAM, 1/10 of a CPU. And it turns out that Java works the best on 1 CPU, which is roughly 1.7 gig. So if you run your Java workload with 1.7 gig of RAM, you will save money. You can do your own, calculations, but this is what's because, the ratio between what you pay for memory and the invocation time are the best, and it runs the fastest. So, and now we have Quarkus. Quarkus consumes maybe at most 100 megs of RAM, and we have 1.9 gigs of spare memory to play with. So there is actually no reason to optimize the memory in Java. It doesn't matter. We could use GraalVM, but why? It doesn't matter. And by the way, this GraalVM, if we would use GraalVM, it will contradict the serverless idea. Why? Because if you think about this, right, what GraalVM does, you have to build it and you have to ship it, so you are in charge of the GraalVM. But if I just ship Quarkus, this Java runs already in the cloud. I don't ship Java, this is patch for me. So if I use Mandrel or GraalVM native image, I have to care about the native image. But if I just ship the business code, the cloud provider have to care about the business code. So this is the basic idea. Very good?
Yes, I believe that especially for serverless, maybe GraalVM could make sense for the much lower startup time because, one of the problems of Java is the startup of Java virtual machine.
Quarkus is too fast. I don't know whether you know Quarkus. But for Quarkus, it will start in 1 to 1.5 seconds. And in Frankfurt, the function, mostly I use the Frankfurt data center. And in Frankfurt, the function remains for 70 seconds warm. So you get the first, the first is you have to wait 1.5 seconds, and the subsequent calls are faster. So it means if your application is called once every 30 seconds, you don't have the problem. And for enterprises, what I can tell them, we can run Kubernetes all the time and pay 5K, or we can pay 15 minutes. We write a cron job, which calls the function every 20 seconds, and maybe once a week you will see you have to wait 2 seconds until it starts. This is the official deal. When I say, okay, then I will save the 4,900 euros, and one of the our student in the morning will call the application first, right? You have to just explain it, what it is, and this is the trade-off. What GraalVM or Mandrel, you have to run it on-premise data centers, because if you run it on-premise, you can drastically reduce the memory footprint. And I even did a podcast with Quarkus. They migrated to Quarkus, an insurance company. This is officially on my podcast, and they were able with Quarkus and I don't even know alone with Quarkus reduced the amount of memory by half. So they can run more in own data center. Just in the serverless case, it depends on the service. Because you cannot just buy CPU, you are buying CPU with RAM. Okay? So enterprise applications, the architectures, this was the last slide, and now a little bit code. So for code, I need my nuclear protection glasses for CERN. And now Quarkus, create app, exactly, let's do the CERN. And what I would like to do, you can see this, right? We have all good eyes, we are young developers. So just open the application. And this is stock Quarkus, nothing special with it. What it just is okay, Docker, we can delete. It looks for me, like always look like, it is Jakarta and MicroProfile. This is my old code forever, and this is the standard code in Quarkus. So what I could do, right? What you do here in CERN, like some proton racing stuff, right? So and this is application scope. So in serverless, only application scope makes sense because there will be never 2 threads. By the way, for me, who knows EJBs? Enterprise Java beans. Very good. Who like them? No one. The cool story is EJBs and Lambda, the same ideas, one-to-one. So I give a talk again, just to know to EJB developers, all the concepts on EJBs apply one-to-one to functions, everything. And one is, in EJB, there will be never 2 threads inside an instance. There will be never 2 threads in a Lambda. Different reasons, the same effect. Means request scope doesn't make any sense in AWS Lambda. So if you know EJBs, be proud. Now you are, the young serverless developer. So now everyone waits for collisions, right? So collisions. return happen. Why I'm doing this now? Actually, just to show you that dependency injection and whatever are also working, plus system current time millis, and maybe do this string message, and with Quarkus I can just do this, which is a little bit Quarkus proprietary default. I don't know, doesn't matter, forget the content, is just name is more important, is message, and of course then replace it with this. So just go this message, and to make it MicroProfile conform is this would run everywhere. So this is now a Java MicroProfile application, runs Quarkus, Micronode, OpenLiberty, Glassfish, and whatever I just talk about the recent years. And and now inject the stuff here. And by the way, do it the Quarkus way, Quarkus or Maven, Quarkus dev. I could run, this is more. So it starts, and Firefox maybe, or not Firefox, is curl localhost 8080 / I think hello, no greetings. So this is reactive, of course. So this is the reactive, and now change that to add inject Proton Racing. And with that, there's Proton dot collisions, and should work, right? So this is working, it's not nice, but it's working. So this was not serverless yet, right? So not that you say, hey, great. So, and now I explain you something. Watch this. So I go here and do Maven package. So if I do the Maven package, what happens now is that I get errors from system unit tests, which are optional. And just do it once again. I never use REST assured, by the way. I always use MicroProfile REST client for different reasons. But in the break, I can explain exactly why. But okay, now it's packaged act. What happened there? Quarkus app. There is a Quarkus run. You see this? So I can run it in Docker. But today is serverless. So I just do clean, and now it's gone. And what I would like to do instead is just another extension. It's called HTTP. Amazon Lambda HTTP sounds good. Always, whatever you do always. So, and then clean it again. Okay, did it, and Maven package. So now, what happens now is I have on the target function.zip. So what it means is, on the first slide, as fun, I prepared today, and I did this. Shift left and right. So what shift and right means is, shift left is our developers shifting left, and right is production, development and production, right? And there is what we should do at development time and what we should do in production time. So like shift left security and shift right testing. In serverless, we can do both. The most asked question is how to test your serverless applications. So let's do this. So the Quarkus still runs here, and it doesn't care about anything. And I say, okay, I'm just Quarkus, I don't care. The one extension, I don't care. So I can test my entire application locally. So what I do right now is, what I would like to do is to create CDK. So setup function, just not to forget things, I tend to automate them sometimes. So setup functions, you are a CDK only AWS project. And what I would like to do is, this I just created for the show, I have to admit. This is just the infrastructure without the business code to explain it. Usually, if you go to my GitHub account, you will always get Quarkus with the CDK. But what I wanted to show you, I can start with a simple Java application and then migrate it as serverless, and even run it on bare metal in Docker and as serverless, the same business code, right? Okay, and now call it CERN infra, or just infra is shorter. So, and this is now AWS code. On Azure, we would use Bicep. This is also a programming language. And what happens here? Okay, so I have here my source main Java CDK app. And what you see, I created a small builder pattern. It says airhacks function URL is prepared is the function name. And the function name, let's change it to Proton Racing. And he asked me now where to put the function zip from, and I think it was CERN. So I will say, okay, deploy the function zip was created earlier. And in this project, so this is for instance, here, I have my Quarkus Lambda, and what you see, I'm just saying, hey, depending on crack or not crack, snap start or not snap start, I can pick Intel or ARM. ARM is cheaper. And please use Java 21 for me. So I don't have to ship Java, I'm just shipping the function zip, which is actually pretty cool. This is what I always wanted to have with application servers. I don't care about your stuff, I only would like to ship my ThinWar and don't care about your things. So this is like ThinWar's next step. Okay, so actually the entire show I could do with that, but this is not the reality. In the reality is I would like to use Aurora database or S3 bucket or DynamoDB table. So I would create a table and then connect it with the function, and the permissions would be created for me. So infrastructure as code included, right? So now go to the function, to the CDK app function zip. This should work actually. I can say I would like to have a configuration map of, and I've wrote the small wrapper as a builder just for fun. And the message is what? Lots of collisions. We had, I think, are different. So, and I think this is basically it. So what I can do, can't build and deploy, don't ask. What this does is Maven package CDK deploy, so it copies it to the AWS and shouldn't ask me, just do it, right? Otherwise you say, okay, I would like to do this. Would you really like to do this? Like, yes. So let's see. So let's run the code. So I have to upgrade Node.js. I was too lazy. I don't. So, and what happens now? Everything is packaged and deployed to Frankfurt, and I get an ugly URI back, which I can call, and we will see the absolute cold startup. So the entire infrastructure, the very first is the cold one, and then it will be hot again. What means is we code the entire infrastructure with Java exactly this way. So I extracted this for conference purposes. I didn't have it before. If you go to my GitHub account, you will find like CDK with Quarkus, and this is what I use always in production. And you will wonder why there is application load balancer, API gateway, everything inside, because depending on the projects, on the heavy load, we use application load balancer. On low load, we use HTTP API gateway. If we, for instance, need API keys or throttling, we have to use the REST gateway, which is twice as expensive but has more features. So again, clouds are about cost. If you don't do this, it will be so expensive that the next year you are back home again. Repatriation is the business term for it. By the way, in one project, I also explained, with architectures and stuff like that, and they say, okay, we don't care, we have unlimited budget. So for me, it was really hard what to do. So, okay, whatever I explained doesn't make any sense. So the best possible case would be to buy a huge machine with 100 cores and just run whatever you like, right? Because it doesn't make any sense to think about such a thing to show you right now. It's just a waste of time. So, okay, but we have here the wonderful URI, and as you can see, this URI is only feasible for conferences. Usually, you can have a custom domain, of course. So, but I will have to set up Route 53 with a certificate. It is not a problem. The only problem is to create the DNS. This is the only problem here. From doing, not a problem at all. Hello, and you will see. Maybe I have a macro with curl t. It measures time, so we will see how slow it is really. And we see the entire round trip was 3.5 seconds to Frankfurt. API complete cold start of Quarkus and back. So now subsequent call was, this is 100 milliseconds. And 2 such calls per second the entire month. Can run for 15 euros my entire enterprise monolith. In projects, we have several hundred classes, packaged as Lambda, exactly the same. No dependencies, our code runs perfectly. We deploy it once, there is no load balancer, no infrastructure, nothing, it runs. By the way, the function URL you see here is not a toy. When the URI doesn't matter, it's the cheapest possible way to run it, because you don't have to pay for the API gateway. Okay? So, let's see whether it is working. Yeah, it is. It is, I don't know, hopefully. So lots of collisions. As you can see, the configuration was overridden from Quarkus by AWS using standard Quarkus MicroProfile. No idea how much time I have, but we are faster than expected, actually. Usually there's something happens, but yeah, today it just worked. So any questions maybe? If not, I could create a table or whatever just to play a little bit more. But the point, I think, we could expand it, but I could iterate locally. Oh, now, questions regarding testing. What if we create a proprietary DynamoDB table, right? If you think about this, the DynamoDB table or Cosmos DB, they run in the cloud, not locally. How to test the stuff? There are attempts to emulate locally the entire environment. The question is why? What I'm doing is the following. I'm running tests, I'm debugging my local running Quarkus, and the Quarkus can absolutely communicate with the cloud. So you have your resources in your dev account, the Quarkus communicates, and as you can see, my Quarkus is still running. So I have my local Quarkus, it's exactly the same code as Lambda. Okay? Now, only Quarkus can do this. What we can do right now, I told you about the events. So the events are emitted by application load balancer in the cloud. Okay? So one consumer is AWS Lambda. But behind the same load balancer, you can put an EC2 machine with Quarkus jar and a Docker container. And now you can run the same business code as serverless, bare metal, or Docker. The question why depends on the load, right? You could say, I have for peaks, Lambda scales like crazy, and I have a base load, a very small EC2 machine, which just is there to avoid cold startups. I don't do this because it is additional complexity, configuration complexity, but it's absolutely possible. And the cool story, what I like, is the same old code, right? Now, Lambda, forget about Project Loom, doesn't make any sense. But Quarkus already supports Loom, so we could run on the EC2 machine millions of threads. Not a problem. Okay, now, how fast or slow was it really? So let's say whether I can find it, CloudWatch logs, AirHacks Proton Racing. What happens behind the scenes? We got the log aggregation as well. So this is the call stack. And what we see is that the init duration of the entire MicroProfile application on 1.7 gig of RAM took 2.5 seconds, but we are not paying for 2.5 seconds. We get charged for 280 milliseconds. So the first call was the slowest. All subsequent calls are 10 milliseconds. So I would pay for 9 milliseconds, 7 milliseconds, and 5 milliseconds. So this is on one core AWS Lambda production Quarkus without any optimizations, no snap start, no growl, just nothing. And this is the puristic, serverless. Okay? Questions regarding this? So I would say measure and then get your opinions. Just say, okay, Java is not usable in the cloud. This is absolutely usable. I think I've even recorded a YouTube video, compared this with Node.js and the Python. Java is, of course, faster. And what it means in my projects, if this is 10% faster, we save 10% money. It's cost savings. The first time in the history of Java, you will see the impact on the invoice. Really. So, and the entire time, I was challenged with the host people. They can measure everything, and we have no idea what they are doing. And now we can show pay per request. Now we have it, right? Okay. Questions?
How did you get those information? How do they come in the logs?
Okay. Lambda, if you create the Lambda, the name of the Lambda, a CloudWatch group is created. A CloudWatch group is a folder, and every instance of Lambda is a stream. And what I have installed is AWS in this Visual Studio Code. There's a free plugin. It's called AWS something plugin, right? And with this something plugin, I have here the information to my account, which means is, I hope it is not recorded. No, I cannot do this. I could go to my account, and you will see a folder with that. So this pulls via the web services the data. Mm-hmm. This is CloudWatch.
Lambda is logging and CloudWatch is...
Yeah, and Lambda is logging, yes, and CloudWatch is receiving. But good question. My business logs I could write in system.println. No kidding. This is what I'm doing. I have an interface with system.println because it doesn't matter. And because there's only one thread, there is no contention. You know, the synchronized and out, I don't care. So it works. So, but important point about you watch my talk and you ask me, you know, what my opinion to databases. We have sometimes you have no questions, so which is unusual. But what is cloud native? Now, because we have deployed Quarkus, it will work. We can iterate, it will work. But I mean, what's the point, right? If you think about databases, because you asked me about that, the problem is something like relational database in the cloud is very important. Expensive. So what means is you will pay for Postgres on Raspberry Pi roughly 500 euros a month, and with backup twice as much. But they are serverless databases like Cosmos DB or DynamoDB, and you pay per request, and you do nothing, right? So what I do in the serverless Java cloud architectures, we spend some time to think about the protocols. In clouds, there are two parts. Control plane, this is how I deploy the application, and data plane, how I use the application. And from my perspective, both has to be supported by the cloud and HTTP. Why? Because then, this was your question before, if my control plane is HTTP, I can provision with CDK the table, set up the permissions, set up everything, and I'm ready to go. But if I'm running Postgres in the cloud, which I like, JDBC, the native Postgres protocol, is not the control plane of the cloud. So I get empty Postgres, empty Kafka, empty Prometheus, or whatever. They don't know that they're running in the cloud. And then I need step 2 to use a different machinery to set the entire stuff up, right? So this is also important consideration what serverless really means. Serverless means I would like to automate everything as easily as possible. So then I am DevOps engineer, right? Cool. What's wrong with you? No questions. So then maybe, I don't know whether we have time or not. I completely lost control now because you are so quiet, so I'm not custom, and we are faster than expected. So what I could do, I could try, this is the stack, by the way. This is the function URL stack, and what this stack is like the state in the cloud. And I just created a builder. This was built by me, and the AWS code is actually just this. My builder made this nicer. And I created the Quarkus Lambda and exposed the Lambda as function URL. This is basically it, and this is the function URL. So what I could do, I could say I would like to have a table, and a table builder create this, and let's call it protons. And then billing mode is important, and there are provisioned or pay per request. I would start with pay per request, and if you know your load, switch to provision. It is 20-30% cheaper. Then table name, let's call it, of course, protons. And I hope is no, I need the sort key, or no, partition key at least. Partition key. This is like the primary key. What is it? This is attribute. I think this is attribute. This was not planned, but I'm working with the stuff right now. I try to remember what you need. Is name is just call it PK. It doesn't matter. And the type is S. Attribute type S is for string. And I think builder build. We good to go? Build. So what I get back is a table. And now, this is Java, the magic starts. Because what I can do right now is, this is my table, right? Here I have the function here. And I can say, okay, cool, table dot grunt read write data to my function. And now, and this is, by the way, all AWS. No third-party open source AWS. And the cool story is, because I did nothing in the cloud, right? So let's run the code again. Wait a second, where was my... So what will happen, the roles and permissions are set up for me by AWS. And they are hardwired. It means only the function will be able to access the table, no one else. Try it by hand. I don't know whether you saw this, with the roles, all the permissions. And the cool story is, for me, if we do this, and we didn't touch the console today, the truth is here. So to audit the security, you only have to look at the Java code. And now the cool story last. This is Java code and this is Maven. I did it now. I could package a jar, push it to a Nexus, and a new developer just download this, say new service, and we are done. So what I can tell you, Java is the best in the cloud, right? So developers like it, and we are crazy productive if we do it the right way. Of course, if we do it a little bit Java, then SAM templates, then CloudFormation and Terraform, you have 50 tools and no one knows what's going on. Right? But if you focus and say, okay, just do whatever we did best and automate best, right? So it happened. So what it means is we have here a table. I cannot go to my. Do I have Europe Frankfurt? I don't even know whether there's DynamoDB schemas. No. But we have the Protons table. It was created right now. And Jack Vienna, I have to it was just a Jack. And usually I use S3 buckets, but they're a little bit dangerous because the names have to be unique. So this is not that good for conferences. DynamoDB tables work better. And what you don't see is the entire security is set up for you. This is completely coded. So what do? We create these services and we stitch them together. Question? To HTTPS? Yeah. This is HTTPS already? Yeah, but you have to connect to a third-party service, HTTPS, and you need to ship a certificate in your deployment. So then how would it looks like this thing, a deployment? When you are the client, then you need to reach a server. A Lambda calls another Lambda via HTTP is not that good idea. Okay. It's not that good idea, but what you could do, for instance, use Event Bridge. It is free, cheap, JSON, super simple, and this is how we communicate between lambdas. It's called Event Bridge, very easy to use, 2 lines of code, very cheap, millions of events. It's not a standard, but 2 lines of code. So Event Bridge is my favorite right now. You can route on whatever. This is JSON. So you use JSON-B, 2 lines of code, and you can send message. And this is not blocking. With HTTPS packaging, how you will do this will be the job of Quarkus. So under source main and resources, you can store the certificates and the client will have to pick them. So there is no difference. And if one Lambda, but there is a cool hint maybe. If you're using function URL, you can call it via Amazon SDK. And the cool story is, this is no more HTTP, but the Amazon SDK cares about permissions. So you can set up your permissions. So if you use your SDK, the problem is also solved. So if you have 2 lambdas as function URL, use AWS SDK, the certificate problem is solved. If you would like to do it by yourself, source main resources, put your certificates, and you have to pick them up with Java HTTP client. You have to load them, right? There is no magic. But my favorite would be to use either Event Bridge, the simplest, but it's not for heavy load. It's like events, more or less, right? Kinesis is like Kafka, but manage is for larger load. SQS are like topics, and SNS is, SQS is like queues, and SNS like topics. Cool. Any other questions? Now it's getting more and more interesting, right? So the other are clapping. Maybe we are over time already. I have stickers, lots of them, but you can have nice stickers, hopefully nice. If not, I will spend a few hours here, so you can ask me, approach me, ask questions. And this is what I'm doing. I hope there will be no more heat to say, you are crazy, it will never work what you're doing, but it's working what you are doing. And it is cheaper than expected, which is really nice, also my clients like it. Of course, everything is trade-offs. You have to know them. This is not a silver bullet, not even golden bullet. This is just another bullet, right? So, and what I don't understand why everyone uses Kubernetes, and I ask why. The answer I get, because it's cloud native. It's like, come on, this is like, you can say VMware is also cloud native, a virtual machine. I mean, yeah, you could do this if you have reasons, but you don't have to. That's the point. Okay. Okay, cool. See you next time.